Okay, my name is João Magrinho and I'm a mechanical engineering researcher at University of Lisbon in Portugal. Deep drawing is a crucial industrial process used to produce sheet metal parts, and to control and understand the behavior of the material, it's essential to characterize both the mechanical and the formability properties of the material. At University of Lisbon, we perform different tests, in this case tensile and Nakajima tests, to characterize the material mechanically and the formability of the material, and then we carried out deep drawing trials to characterize, to study the forming process in detail. Together, these experimental activities provide a solid foundation for developing for more efficient and sustainable sheet metal forming processes.
I'm Tony Travieso. I'm professor of mechanical engineering department at the UPC and researcher in the manufacturing technologies group. Our contribution to the project has been to develop an ultrasonic vibration assisting cutting process. The objective of this is to create some craters along the machine surface in function of the cutting parameters used, looking for a better coefficient of friction and a special texture. This is a very good alternative process to the texture surface because it is very efficient and sustainable if we compare with the traditional ones used for the same purpose.
My name is Philipp Schumann. I'm a PhD researcher from PTU at TU Darmstadt, Germany, and I was supervising and mentoring the German students. In my research, I focus on improving and increasing the sustainability and process efficiency of different manufacturing processes. Therefore, I created a specific kind of incremental forming processes, which is machine hammer peening using a specific kind of microtip. The microtip creates a deterministic texture on the surface, where those dimples serve as particle and lubrication reservoirs. These reservoirs serve as lowering friction and also lowering the wear in the process. So therefore, it was a really nice opportunity comparing this process and applying it to a specific kind of metal forming process, such as deep drawing, and comparing it with the texturing process of UPC. This is why the cooperation between Lisbon, Barcelona and Darmstadt was a very nice opportunity on collaborating and using all those techniques together, where different levels of academia can benefit from. Therefore, we developed a research and educational project.
So for us in Darmstadt, we did two parts. We provided one texturing process with machine hammer peening, where we textured the aluminium blanks that are to be used in the deep drawing. And for this, we also investigated the surfaces. Additionally, we did a simulation, FEA simulation of the entire deep drawing process also in Darmstadt, just to later then be able to validate if we changed actually the coefficient of friction and how much, and to evaluate the results.
In Lisbon, we started by doing the material characterization. So we did material testing, tensile tests, Nakajima tests to evaluate both material properties and the formability to predict how the deep drawing will go on a more analytical basis. There are still going to be more deep drawing trials in Lisbon to test some more hypotheses about the microtexturing and how deep drawing will work with these new techniques.
Well, from Barcelona part, our main contribution was to texture the samples provided by Lisbon by a removal material method called RUVAM, that means Radial Ultrasonic Vibrations Assisted Machine. We decided to use this technique in a lathe machine, so our contribution was to mechanize this texture in the samples by creating a support tool to take this aluminum plate and then apply this RUVAM method into the microtexturing for further away study how this microtexture may vary the roughness and the lubrication properties applied to it, and then also see after this mechanization how it could modify this mechanical behavior on the samples.
In our case, we actually wanted to compare it with the literature, but we didn't have exactly the same approach as the literature that we based our study with, because they were using more of a circular trajectory and we were doing a spiral trajectory, so we couldn't directly compare the results. But what we did to actually compare them was, on the one hand, we did multiple tests with the same parameters to try and see if there was like a constant pattern that was being reproduced, and then those trials that had a completely different result, they were just discarded as bad results. And also we could check with the parameters that we could have an idea of where the numbers should be. We could, because of the literature, it shouldn't be exactly the same, but we could see if the results were valid, if the numbers made sense or not.
Our results were validated mostly by our tests. For example, in some cases, in the material testing, we used digital image correlation, so a setup of cameras that recorded the test, and sometimes the system is not accurate enough when you have, for example, localized deformations which are very large. So we had to use microscopy to evaluate some thicknesses to calculate a more accurate value, and obviously always comparing to literature, so it's necessary.
So for TU Darmstadt, we used to evaluate the microtexturing, we used a microscope and analyzed the surfaces and compared them with each other. And with this we decided how to texture the blanks the best way to achieve optimal results. The deep drawing is used to validate the results from the microtexturing, that it actually impacts the friction and that the lubricant pockets work. Additionally, for the FEA, it was validated through the experiments done in the deep drawing trials done in December in Lisbon, where we got results to compare with the numerical solutions.
So I think our biggest challenge was to find a clamping system that was actually working. We faced a lot of problems with that because we were trying to texture the piece, but sometimes we were having some problems. Not all the piece was getting texturized, or maybe it was getting smashed and it was breaking the piece even. So we had to make a lot of attempts with the clamping system until we find the last one. It's still not perfect because we still face some problems with that clamping system, so in the future it should be improved, but we managed to control the vibration the best that we could and to have a smooth pattern on the blanks.
From my point of view, the biggest challenge I had was to get the simulation running itself. In particular, one problem was that we did not have the possibility yet to determine the friction coefficient of the friction pairing we had in the test, in the physical test. We had to guess a little bit, and we did the parameter studies on that, and then we compared it to the physical tests. When the result matched, that was the sign for us that we chose a good friction coefficient.
Well, in Lisbon there was a big worry, which was that our material has the Portevin-Chatelier effect, which is, in simple terms, makes a very jagged, very inconsistent material properties. And so to evaluate them, you need to do a lot of filtering and looking at the results with, you need to analyze the results with some cynicism at times. You can just take every result for what they are. And so you had to do some extra analysis on all the results that you got.
My advice for the next coming students is if you're going to start this type of new project that is related with texturing, and you are measuring things that maybe you don't have enough literature to compare, or you are kind of searching a little bit in the unknown, don't be afraid to start recording and tracking all the results, because even though you are at the moment not seeing something, this record later on might be useful for you to track some behavior or problems that may lead you into a solution. So be methodical and don't be dismotivated, even though in the beginning you don't see things are working, because it could all the steps are important. So it may help you at some points to find a better solution.
I would also advise maybe to communicate a bit more, or maybe in earlier stage, because we went to Germany, but it was already more or less the middle of the project, and we realized that we were actually more or less facing some similar problems. So maybe if we would have been in contact before, maybe we could have solved these problems all together.
First and foremost, communicate more. I think, looking back, I think we should have communicated more between universities. Within university, it was very smooth, everything went well. But between each university, I think sometimes it was very easy to get lost between what we were doing and what other people were doing. Sometimes the objectives of why we were doing our things were unclear, and sometimes because we didn't know what things were needed for, we ended up doing things maybe not in the easiest way. Maybe we could have done something that would have made work for the other people at TU Darmstadt and UPC easier and smoother.